Hello, today we're going to be talking about earthquake triangulation, or how we find the epicenter, the origin, the point on the ground where the earthquake started. So we do this by studying the seismogram. The seismogram is a graph that shows the intensity of waves as they show up. Remember, P waves are the fastest. They show up first, then S waves, and then you get the surface waves like Love and Rayleigh. So the first step to finding where an earthquake originated from is to figure out the distance. We know how fast the P and S waves travel, and we can figure out how long it took them to get there. So with speed and time, we can get distance, because distance is equal to speed times time. So when we are looking at a seismogram like this, you can see the P waves show up first, the S waves show up later, and what we're interested in is the time in between, to count how much time passed in between the P and the S waves showing up. Then we can plot these. Since the speed of the P and S waves are known numbers, we can double check in a lab and we know exactly how fast these kinds of waves travel. We can create a graph that shows the time it takes for the P and S waves to show up compared to the distance in kilometers. So some graphs will show both the P and the S waves. You can see here the P waves show up first, the S waves show up second, 5 minutes in between, meaning it was almost 4,000 kilometers away. This is another version of the same graph where it shows the different time it takes P waves to arrive and the different time it takes S waves to arrive. And then a third line is S minus P, or what is the interval in between, how much time was in between them. The S minus P is what we'll be using most often to triangulate earthquakes. So if I know that there was 40 seconds in between the S and P waves, I would come over to 40 seconds, look to see where my diagonal S minus P line meets that, and trace it down to see that that would be about 390 kilometers away from the epicenter. So now I can figure out distance, but I don't know what direction that distance is. I just know it was 390 kilometers away from me. That could be anywhere around me in a circle. So we have to use something called triangulation, or using at least three. It can be more, but try is three to figure out where this happened. So let's say I've got these three seismic stations. A down here by the Four Corners, B in Baja California, and C in Central California. And station A, I look at the seismogram, I look at my graph, and I see that the quake was 850 kilometers away from station A. That means I can draw a circle around station A, and every point on this green circle is 850 kilometers away from A. So there's lots of options here for where the earthquake could be. But at station B, I found that it was 400 kilometers away from station B. So again, I can draw a circle around station B, and now there are only two spots. There are only 2 points on the map that are possibilities. Both of these intersections where A and B circles cross each other, those are points that are both 850 kilometers away from A and 400 kilometers away from B. I'm not done yet though, because I have two options, and the earthquake only happened in one spot. So I'm going to look at a third station, station C, and I found that it was 550 kilometers away from station C. So I draw a circle around C, and now I can see all three of those circles intersect in one spot. There's only 1 point that is the correct distance away from each seismic station, each recording station, and boom, there it is. That is where the earthquake happened. So that can tell me where it was just by looking at these seismograms. I can also look at that to figure out the magnitude on the Richter scale. Remember, the Richter scale looks at how big are the actual waves. So if I go back to the seismogram, looking at the waves, what I want to look at is how tall are the S waves. And normally when you're reading a seismogram, there'll be a little ruler next to the side so that you can actually measure how tall these are. But I want to look at how tall are the S waves and how far away was the earthquake. So you'd pick one of your seismic stations. Here I picked one that was 100 kilometers away. And I found that the tallest S wave was only 1 millimeter tall. So I would draw a dot on the distance graph on the side here, then draw a dot on my amplitude graph and connect the dots. And I can see that when I draw a line connecting these dots, it crosses the Richter scale at 3. So this example earthquake has a Richter magnitude of 3. And now we'll look through an example together so that you can see how all of this breaks down. So let's look at an example of how we can actually read seismograms to figure out the magnitude of an earthquake. So here I have recordings of an earthquake in 3 different locations. There's Boston, Denver, and Sacramento. And the first thing that I need to do is figure out how much time passed in between the P wave arrival, which is always the first one, and the S wave arrival, which is always the second one. It shows me down here at the bottom that each box is 20 seconds. So it looks like at Boston there was 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280, 300, 320, about 340 seconds was the lag time between the S waves and the P waves. That's how much time passed in between the S and P waves. So I'm going to go ahead and mark that is 340 seconds. I'll do this for all 3 so that we can then move on to finding the distance. So looking at these graphs, I found that it was about 260 seconds between the P waves and the S waves showing up in Denver, and about 310 seconds between the P waves and the S waves in Sacramento. Now I need to go and look at that graph to see how these times relate to distances. So I'll think first, I'll remember the number 340, and down here I've got a graph that shows me SP interval, or the time in between S waves and P waves, and distance. So I want to find 340 on the y-axis, which is going to be somewhere here in between 330 and 360. I will trace that over, and 340 is pretty close to in the middle, so I'll say it's about there. Trace it down, and I get a distance of 4,000 kilometers. So I will go back up to my seismograms and record a distance of 4,000 kilometers. And I'm going to repeat that for all 3 seismograms. With my distances that I found from the lag time and my graph, I need to draw some circles around the cities. Remember that 4,000 kilometers means that this earthquake happened 4,000 kilometers away from Boston, which means it could be in any direction. So my circle has a radius of 4,000 kilometers and is centered on Boston. Now I need one that has a radius of 2,800 kilometers and is centered on Denver. So I'm going to use my little scale down at the bottom and draw a circle that has a radius of 2,800 kilometers, about there, and move it so that it is centered on Colorado, right? Let me double check. Denver, Colorado. So I want to put my circle so that it is centered on Denver. And now I can see there are 2 places where my circles overlap, near Watson Lake and near Acapulco. I'm not done yet. I need to look at Sacramento. I have a distance from the epicenter of 3,600, or my radius should be 3,600. I added little pink lines on the side here as kind of reference for me, since this does not go to 4,000 and my radius for Boston needed to be 4,000. So that is about what I need the radius of my final circle to be as well. A little bit smaller. And that is going to be centered around Sacramento. So I will move this circle, change the color too so that it's a little bit more clear which one is which, and move this to be around Sacramento. And now when I've got all three circles on the map, I can see there are a couple places where two of them overlap, but there is only one spot where all three circles overlap, and that is down at the coast of Mexico. So this earthquake happened, the epicenter was down in Acapulco at the coast of Mexico. Now I want to find its magnitude. I'm going to pick just one of these. It doesn't matter which one because they are all referencing the same earthquake, but I'm just going to pick one of them. I'm going to look at the seismic station in Denver, where I've got a distance of 2,800 kilometers. The other thing that I need is the height, the maximum amplitude of the S waves. So if I look on the side, I've got a scale and it shows that the maximum amplitude of this S wave is 20 millimeters. So if I come look down at my nomogram, I can make a little note. The distance was 2,800 kilometers, or right about there. I just said I had a maximum amplitude of 22 kilometers or millimeters, excuse me, which is right about there. And now I want to draw a line connecting those two dots. And that shows me it crosses the magnitude scale at an 8. So the magnitude of this earthquake would be about an 8.0 for this earthquake measured in Boston, Denver, and Sacramento. And that is how you triangulate an earthquake and you find its Richter magnitude.